Hi, hello everyone. Thanks Daniel for the introduction. Today I'll talk about monitoring. I'm a system software engineer, Sysdig. So since a year ago, I work every day dealing with low-level troubleshooting and especially in container-based environments. In the past, I've been a backend developer where I developed backends and deployed also microservices. So I have a bit of experience on this. And let's start from Docker. Everyone here knows Docker, I guess, so I'll go faster in there. But just to say that Docker is good because it's able to bundle our application in an easy way. We can easily create a single immutable unit for our application and run it potentially everywhere. It's easy to replicate environment between development of laptop mainly, or going to continuous integration, or going to production environment. So it's very easy to iterate on development and go fast on this. But when we want to go in production, we need something to manage our containers, run them, ensure that they have enough resources to run, manage so all the lifetime of our application. And operational people like a lot Kubernetes because it's an easy way to deploy our application. It's backed by 10 years of Google experience on container at a huge scale, and you can find this when you look at the design. When there is nice abstraction like services, replication controllers. So if you want to talk to another service, you just have a single entry point, and doesn't matter where the service is deployed. And also you just say I want 3 copies of this service, and Kubernetes takes care of everything. So tools like Kubernetes are very good to manage a cluster of containers, but when you go in production, one of the first thing you think about is monitoring, because monitoring is important to get insight of how our application are doing, how they are performing, which kind of resources they are using, and also if something bad happens, it's useful to understand that. So monitoring is one of the most hot topic. What was monitoring before Kubernetes? Before Kubernetes, usually the common deploy for microservices architecture was a single app on each host. So you have your app, you bundle it usually in a custom way to install everything on your host. You use, for example, a monitoring agent to install on that and pull all the metrics needed. And it was quite easy to do this because the environment was simple in a unit of a host. And also, if you log in on your host, it's easy to understand the CPU usage or memory usage, because mainly there is only one app that's using a lot of CPU or a lot of memory or all the networking resources. So it's easy to get inside them. But after Kubernetes, now we have many apps on each host. And also we don't know where our app will be deployed. So when you go inside your host, just log in and use SSH. If you run top, you see a bunch of processes, and you don't know there is not an easy way to understand the resources, how they are used. Also, containers are for some things, containers are like virtual machines. Like if you think about networking, from the host you can see the networking of the container. They have a totally different network stack. So if you want to troubleshoot networking with TCP dump, you can't, because if you run TCP dump on the host, you don't see the traffic of the container. You may need to run TCP dump inside the container, so install TCP dump inside the container, and it's a bad practice, because containers should be as lightweight and simple as possible. Also, if you want to install a monitoring agent inside inside the host, it's not so easy anymore because, for example, from the host, the agent is difficult that can find a way to connect to the application, and also you don't know where your application will be. So the agent should be smart enough to do this. So with Kubernetes, it's difficult to isolate the activity of your application when you have a lot of application running on each host. It's difficult to segment the resource usage and get meaningful awareness of what your app is doing. And get visibility inside containers is difficult because they are isolated from the rest of the system. So seeing networking activity is different, seeing file activity is different, and so on. This is a list of a key feature that a container monitoring solution should have. I think that the most important things are having high-level ability to explore and segment the resource usage across your cluster based on Kubernetes services, Kubernetes pods, and so on. So having not a physical representation, but a more logical view of what your cluster is doing. But we also need low-level visibility. If I see that something is going wrong on my app because there is a spike of CPU, I want to go there and see what are the networking that my app is doing. Where is connecting, why is connecting to that, and or what is reading from this file, why, how much, and so on. Also, we want to avoid container instrumentation. It's a bad practice for many reasons. Think about that if you add the instrumentation inside your container, your image will grow and the deployment are slower. Also, if you add more stuff your image, you increase your attack surface. So there are security implications. And the system becomes more with more moving parts, more complex in general. As any monitoring solution, we need low overhead. It should be the low overhead should be as lowest as possible because we don't pay servers to do monitoring, to do our work, and a monitoring solution should be smart on the configuration, should be able to follow my app whatever is going on, if it's across our cluster, and be able to auto-configure all the metrics I need to get from my application. In the Kubernetes world, there is some stuff going on to fill these needs. Starting from Kubernetes UI, you can on the Kubernetes UI see your app where are deployed. So an overview of your cluster, a logical view of your cluster. If you want some metric, you can configure Hipster with Grafana and get the common CPU, memory, common metrics like CPU, memory, networking, files, grouped by the logical representation of the cluster given by Kubernetes, with all the Kubernetes metadata and services, replication controllers, pods, and so on, which is quite useful, as we said. But it misses low-level visibility, and it's very important for us. This is a slide from Brendan Gregg, which is a famous performance engineer working at Netflix. And it's a pretty comprehensive overview of all the low-level utilities that allow us to understand effectively what our app is doing and how. So if you want to monitor networking, you want netstat, you want TCP dump. If you want to monitor resource usage, you want top or vmstat, things like that. If you want to trace your application, you use tool like systemtap or perf and so on. All these kind of tools are useful, but don't play well with containers. Try, for example, to run TCP dump on the host. You don't see at all the network traffic. Or you can run TCP dump inside a container, but you don't see the network traffic of another container, or top and things like that. So with these things in mind, so with these key features that in mind, at Sysdig we are trying to build a product that allow people to get this kind of visibility inside container-based solutions, and I'll show you a little bit of how they work. Here I have a Kubernetes cluster. This is the output of Docker PS, which is a lot of stuff, many containers. With Sysdig, we are able to easily detect and isolate every single application working here in easy way. Sysdig comes in two flavors. We have a command line utility and a courses-based interface. They have both overlapping and not overlapping features. I'll show you a couple of them. I start from the courses interface because it's more easier to start and to get inside on it. So let's start Sysdig. This is like top or htop if you are used to it. The same color, the same colors, and we took from it a lot of inspiration. And as you can see, the process list of your system show you a lot of processes, and you are not able to understand effectively what your application is doing. Even if we go on the containers view, which is similar to what the output of Docker PS, it's a top of all the containers. So it's quite more interesting that the raw top of processes. So we have all the metadata of the containers, like image, ID, the name, and so on. We see the CPU and memory usage of each of them, but it's quite still a lot of information. We have native support for Kubernetes. So, for example, here I see like the top before, but grouped by Kubernetes namespace. So it's quite more easy to understand. I can click on each row and explore what there is inside. In general, in Sysdig, when you click on a row, you get inside what the row is meaning. So if you get inside the namespace, we see the pods. So it's the top of the pods inside this namespace, which is a good logical view of our host, and it's much easier to understand. Like here, no, it's better to. Okay, here you can see there are a couple of WordPress pods, a Java application, Mongo instance, and so on. For example, let's choose the Redis pod. Go inside, I see all the containers belonging to this pod. So we have actually one container. If you go inside here, we see the processes running in this container. If we have the concept of views, here there are different views which are generic. Can be you can expand them if you want. So let's see what this process is doing for other perspective. Like if we go on the files view, we see all the file activity of this on this container. So we are seeing that Redis here is reading a lot of data from procstat probably to get CPU and memory usage of itself, and also is writing some data on a file called append only. So with Sysdig, it's we like this way to isolate the activity of your app very easily, just some keystrokes forward. And we are this is like netstats. You get an overview of the connections running here, and so these are the connections received by the Redis instance. It's able, this is just another view grouping network connections by server ports. There is an echo mode that prints every byte exchanged in these connections. So we see every Redis command going here. And we are able to do this without instrumenting Redis container. Redis container is like the image from Docker Hub. So this kind of stuff is quite useful because without touching the application, we are able to see what it's doing. For example, we can let's go back to processes view. If we press dig here, the dig button down here, we get here now all the system calls called by Redis. So it's like strace if you're using it, and we are able to understand every single bit of what Redis is doing. Like for example, here we can isolate how Redis works. We are seeing here there is a read on a TCP connection, and Redis received a buffer with the inc command. The inc command of Redis increments a counter. And just after, a couple of events after, Redis writes the same buffer on the append-only file. Again, a couple of events after, like down here, Redis answers the client. So here is here, for example, we can understand how Redis is working. Redis is memory-based storage, but allows you to have persistence in this way, like streaming every write command to a file, and if Redis is restarted, all the data is reloaded from a log and reapplied to a blank instance. So we like this way to do low-level troubleshooting very easily because you can, from the whole bunch of applications running on your host, with the segmentation we have, it's easy to dig into on the application we want to actually now troubleshoot. Another thing we like is having the ability to, like we used to do with Wireshark, if you know it, saving a trace file of what's happening, and after troubleshoot it later. Like save all the system events, and with Sysdig can be done with the -w command. And Sysdig runs a tracing of all the events happening in the whole system and saves them in a file. And then you can read this file after on your laptop. So, for example, I can use the command line utility command line utility has a nice feature called the chisels, which are script written in Lua that allows you to do with all the events everything that is feasible in Lua. So, for example, we saw on the cursus interface, which under the hood uses Lua 2, we saw different aggregation like connection, top, and so on. We have here a chisel called HTTP log that tracks all the network event, parse the HTTP protocol, and show me like an Apache log, but for the whole system with the container metadata and besides Apache, so all the analyzing of the system traffic. And there are very few tools in the market that are able to do this, with especially in container-based environment. So our Sysdig is able to capture all the system event in the system. So it's a low-level troubleshooting tool, but it's able also to have high-level exploring of the resources. It allows to filter the data to get exactly what we want, and it's able to aggregate the data with Lua scripting and so on. It's open source, so we released it at open source on GitHub. As native support for containers, and also we work closely with the Kubernetes team, and we support Kubernetes 1.2 and all the version, all other version of Kubernetes released so far. So we have a very deep integration with the container and container orchestration, like Kubernetes. And let's talk about multinode. Sure, when you saw all this, we worked on a single node, and but on your cloud infrastructure, you have multiple nodes for sure. And to get visibility on those nodes, we need this kind of feature, so high-level exploring and low-level troubleshooting. And I'll show you another product we are building, which is called Sysd Cloud. On Sysd Cloud, you get you install an agent which is built on top of the Sysdig open source technology, and the agent does aggregation of the system events and sends to our cloud. And there we provide exploring feature like the Cursus UI does, but from the whole infrastructure. So, for example, if I click the production namespace here, I see all the network activity in this case segmented by Kubernetes services. So it's kind of thing that we need, because it's what we care about, how our services are performing, not our host and so on. We have also low-level stuff, like from the system events, we capture HTTP traffic, as I showed you on HTTP log chisel, and we get also this kind of more fine-grained data. Another thing we like is this kind of visualization that is an overview of your cluster, and represents the problems I talked about today. If you see a classical Kubernetes cluster, you see this host with many containers that are talking each other in a way that is not easy to understand in this kind of visualization. But if you do the same thing with the awareness of the cluster managed by Kubernetes, we see now again the production pod and the production namespace. If we go inside, we see the services. get inside the services, we see the pod and also how they work, because for example here there is the Kubernetes load balancer, and going into we see the containers and the processes. So this kind of features I think that are important in a container monitoring solution, and new kind of tool are needed to do this, because there's something changed after containers, how we deploy, how we set up our infrastructure, and it's a new world. Our apps are more dynamic on handling changes, and so getting visibility into them is difficult, and so we're trying to build tools focused on that. That's it. You can find me on this this email or on Twitter, and also we have a booth there, so if you want to go, you can talk with us, and if you have questions, or we have some time here for questions too.
Yeah, there's plenty of time for questions, so I'm sure there's hopefully a few there, because it's very interesting looking into the microservice landscape and monitoring. Any questions at all?
Okay, sorry, you mentioned you can record the history and replay it later. Can you do something like having a rolling 1 hour window to have the history, and if I notice it's something, I already have the log and I can replay it or analyze it without actually starting it after I find something is wrong? We can do this is the capture that I showed you from the cloud. So if an alert fires from a metric that you choose, you want to choose to set up your alert, we can automatically trigger a capture. So if something goes wrong, you can get a full trace of your whole system and troubleshoot it on your laptop or whatever you want. And it's good to get nice visibility of what happened. Yeah.
Another question over here, Luca.
Hey, so the Sysdig in the cloud thing, do you collect all the events from all the machines, or is it like dynamic when you zoom in and you want to like dig into this particular node and those particular like pods? Is it like actually like creating the event listeners for them on the fly, or is it like completely streamed into the cloud, all of the events at the same time? With Sysdig technology, you can trace all the events, all the system call of the system, but streaming them to a backend, a single point could be as they are, could be interesting, but it's not scalable. It's too much data. We do an aggregation every second of all the metrics we find, like all the processes, with the processes we have also the metadata, like Docker container or Kubernetes metadata, pods, namespaces, and so on. So all these kind of metrics are sent from our agent every second, and the backend can then analyze and do this. So it's not, the agent sends always the data, and after the backend is able to segment them in this way, explore them, and analyze. Yeah.
Any more questions at all?
Is there any performance impact to our applications when you're monitoring consistently at this kind of level?
As I said, one of the key feature is low overhead, and we try to have a low overhead. Actually, just the tracing is a couple of point of percentage on Sysdig. On our agent, we do more work than just tracing, but we have also a sampling mode that automatically discards some events, so not useful events for monitoring. So our impact on the agent is more or less the same, like
5% of CPU usage is our what we think it's a good compromise. And we do this like if there are many events, we do subassembling. So we have some strategies to keep the overhead as low as possible. Yeah.
Nice. Any more questions? Anything over that side of the room at all? Yeah, cool. The question, Luca, is that all right?
One of the challenges is that your app is built by different pods. So you care about your app, which is namely a Kubernetes service. And there are many pods around, so when you want to see the metrics of your app, they are the grouping of all the metrics of all the single pods. And the pods are changing very often because you do all continuous deployment. So Kubernetes to deploys spawns always new pods and then shuts down the older one. So the grouping we need is important. The grouping for us is important to get you the monitoring of your app besides the pod, the actual real pod that they use. Sorry.
So you're taking a specific example there. Say you've got like almost like a PagerDuty style thing. You've got an error occurring.
Okay. Yeah, you can set up alerts from our product, and the alerts are based on the metric, but also on the context. Like you can say, fire this alert if there is too much network traffic on this Kubernetes service, and so setting alerts like this. You are able to get notified if your Kubernetes cluster is not working for some reason, and PagerDuty and so on.
Does Sysdig persist or storage all that information? And if the answer is yes, where and how long?
We keep them right now. Our written policies is forever, but we have different granularity. So for 6 hours we have 1 second granularity, but after 6 hours gets to 10 seconds, then to 1 minute, and then to 1 day granularity, and so less granularity from the more older data.
And where is the storage that the information data?
Where is stored? On our cloud infrastructure. A couple of customers are not aware of, don't want this, and we have also on-premise version for them to store.
Yeah, I mean, most of those are like system-level metrics, like things that you could get out of systrace, or just like analyzing like network packets and stuff like that. What if I wanted to have like application-level monitoring, where I, for example, want to measure the number of like in-memory hits on a cache that I had in my own application? Can you actually define user-level metrics inside the application and somehow fit them into Sysdig?
This is an important question, because application metrics are also very important, and we found that on the container world it's difficult to track them, because, for example, if you used the statsd in the past, you had a single statsd server and you send the metric to it, and configure a statsd ingestion in a container-based world is more difficult. And on our agent, we have a feature that when you send statsd metrics, like if you just send them to localhost, the packet gets discarded by the kernel because there is no server in your infrastructure. But from the Sysdig event, we capture the protocol and we automatically aggregate also this data and send to the backend. And this is, I think, the best way to have application metrics, because the statsd protocol, it's very easy to use, very simple. It's open source protocol. There are plenty of open source servers, and we actually use one of them internally. And using statsd is easy to create this kind of application metrics.
Just out of curiosity, Luca, do you support things like Rocket and Mesos in addition to Docker and Kubernetes?
Yeah, we have support for Rocket and Mesos too. We announced it a couple of months ago. In general, we want to support every kind of container and orchestration system. And yeah, so we have also this. Yeah.
Any final questions? Got a few more minutes. Going on. In that case, one more time. Oh, what's our final question? Oh, snuck in.
I'm going to ask the horrible question. How much does the cloud thing cost?
What the cost?
What's the cost? Yeah.
Of the cloud? Yeah, it's $20 per single host. Yeah.
Right, check out the Sysdig website or have a look at the booth actually as well.
Yeah.
Quite good. Thanks so much to Luca one more time. Thank you, Luca.